is aqueous sodium hydroxide in water, and the sodium ions are separated from the hydroxide ions moving around freely as it dissolves in water. Here, we have dilute sulfuric acid in water. The H ions have dissociated and are moving freely in the water around the sulfate ions. Here, both substances are put together in the same beaker of water. How would they react? The sodium ions and sulfate ions have joined together to form sodium sulfate. However, since it is soluble in water, the sodium sulfate dissolves and the sodium and sulfate ions once again split up to move around freely, apart from each other. Yet, the H ions move towards the hydroxide ions to form H2O, water molecules. These water molecules are held by strong forces of attraction, and can move about and slide over one another. They can also exchange positions with their neighboring molecules. Here, we have aqueous potassium hydroxide in water. As you can see, the potassium ions are separated from the hydroxide ions, and are moving around freely and far apart from each other as it dissolves in water. Here is aqueous ammonium chloride in water, and similarly, the ammonium ions are separated from the chloride ions, which are moving around freely and apart from one another. Now, both substances are put together in the same beaker of water. How would they react? As you can see, the potassium ions and chloride ions have joined together to form potassium chloride. However, since it is soluble in water, the potassium chloride dissolves and the potassium and chloride ions once again split up to move around freely, apart from each other. The single H ions have also broken off from the ammonium ion and are moving towards the hydroxide ions to form water molecules, which are held by strong forces of attraction, and can move about and slide over one another. They can also exchange positions with their neighboring molecules. After the single H ions have broken off from the ammonium ion, the remaining atoms form the gas ammonia. The particles of ammonia gas have weak forces of attraction between them and move freely in all directions. They also are far apart with a lot of spaces between them and are randomly arranged. The presence of ammonia gas hence results in effervescence observed. These ammonia gas particles then dissolve in water, leaving no precipitate behind. Here is dilute hydrochloric acid dissolved in water. As you can see, the H ions have dissociated and are moving freely in the water around the chloride ions. Here is solid copper-2 oxide. The forces of attraction between the copper-2 ions and oxide ions are very strong, holding them in a fixed position. The particles can only vibrate at their fixed position and are very closely packed together, in an orderly manner. Now, both substances are put together in the same beaker. How would they react? As you can see, the strong forces of attraction between ions in the copper-2 oxide are broken after undergoing a chemical reaction between the hydrochloric acid and the solid copper-2 oxide. The H ions are now moving towards the oxide ions to form H2O, water molecules. The forces of attraction between the molecules are strong, and they can move about and slide over one another. They can also exchange positions with their neighboring molecules, as they are closely packed together but not arranged in an orderly manner. Also, the copper-2 oxide and chloride ions have joined together to form copper-2 chloride. However, since it is soluble in water, the copper-2 chloride dissolves and the copper-2 ions and chloride ions once again split up to move around freely, apart from each other. After the copper-2 chloride ions dissolve in the water just formed, it produces a blue solution in the beaker.